Welcome to Delphos Insights. Today we're doing a deep dive into, well, this huge global investment shift happening in AI infrastructure. But we're focusing specifically on how emerging markets seem to be becoming the real architects here, not just followers.
That's right. It's a fundamental shift, really. Our goal today is to unpack how these key technologies, AI, 5G, edge computing, and those massive hyperscale data centers, how they're all converging and how that convergence is, actually reshaping global economic influence.
And the scale we're talking about is just massive, something like $750 billion globally going into AI infrastructure. But are emerging markets really getting their slice of that pie proportionally? Or is it more of a catch-up game?
Oh, it's more than catching up. I'd say they're actively leapfrogging. They often don't have the decades of older legacy infrastructure that you find in the West. They can jump straight to the latest tech.
Okay, leapfrogging.
Exactly.
Yeah.
And that tech is being dictated by the sheer physics of modern AI processing.
All right, let's dig into that physics aspect because it sounds crucial. You mentioned traditional data centers might run at, what, 8 kilowatts per rack?
Yeah, around that. But these new AI facilities running advanced chips, they can demand up to 17 kilowatts, sometimes even more per rack.
Wow, double. That's a huge jump.
Yeah.
Creates serious heat problems, I imagine, and energy consumption issues.
Absolutely. That kind of power density forces innovation in cooling right from the start. We're seeing a big push towards things like direct-to-chip cooling or even full liquid immersion.
Liquid immersion, okay.
And getting this right improves efficiency dramatically. It can cut the power usage effectiveness, the PUE, by maybe 10%.
And PUE, just quickly, that's the ratio of total energy used by the facility to the energy actually delivered to the IT equipment, right?
Yeah.
Lower is better.
Precisely. So emerging markets building brand new sites, greenfield sites, they can bake this efficiency in from day one. They avoid the costly retrofits older facilities face.
That makes sense. So if these new centers are so specialized, where are they actually being built? Where's the boom happening?
Well, arguably the biggest potential is in India. Think about it, they hold maybe 20% of the world's data, yet they only have about 3% of global data center capacity.
That's a huge mismatch.
It is. Closing that gap could mean building an extra 45, maybe 50 million square feet of AI-ready space. It's a massive undertaking.
Truly enormous scale. What about other regions? Latin America?
Latin America is definitely another key area. We're expecting over $2 billion in investment just this year. Brazil's leading the way, taking about 40% of that capital. São Paulo is a major hub, mostly because it connects to 10 major submarine cable routes already.
Connectivity is king.
Always. And interestingly, keep an eye on Mexico. Querétaro specifically is popping up as a sort of unexpected hotspot, driven by some smart energy planning.
Okay, Mexico too. Now, the Middle East seems very focused strategically here. This idea of sovereign technology vision.
Yes, that's very prominent. You see it in the big deals, like Microsoft putting $1.5 billion into G42 in Abu Dhabi.
Right, the AI and cloud company.
Or the Saudi Public Investment Fund partnering with Google Cloud. That deal alone is projected to have something like a $71 billion economic impact. It's about future-proofing their economies.
And Africa. Still early days, perhaps, but are there moves there too?
Definitely making moves. Africa currently has a tiny fraction, like 0.1% of global capacity. But you see initiatives like Zimbabwe partnering with NVIDIA. They're building the continent's first dedicated AI factory. It's about building local capability from the ground up.
So this whole build out, the data centers, the AI factories, it all depends on connectivity, doesn't it? That brings us to 5G.
It's absolutely foundational. Global 5G connections hit, 2.25 billion users late last year, growing faster than 4G did. But for the really advanced AI stuff, the low latency applications, think autonomous systems, remote surgery, you need standalone 5G.
Explain that difference. Standalone 5G.
Right. So standalone 5G or 5G SA, it doesn't piggyback on the older 4G network core. That independence is what gives you the ultra-low latency, the near-instant response times that AI applications demand.
Got it. Faster, more direct. And underpinning all this investment, all this tech, is policy. Capital flows where the rules make sense.
Exactly. And EMs aren't just adopting tech, they're innovating on policy too. Things like targeted tax incentives, smart ways of managing radio spectrum, setting up regulatory sandboxes to test tech quickly but safely.
So it all ties together. The hardware, the software, the connectivity, and the policy framework.
And it's all driving towards, I think, one central goal: AI sovereignty.
AI sovereignty. Define that for us.
It's essentially the capability for a country to develop its own AI, deploy it within its borders, and govern it according to its own rules. It lets them optimize their own operations, secure critical data, and avoid becoming dependent on external powers for this core technology.
So looking ahead, it seems like the governments that manage to blend this massive investment with smart, forward-thinking policy reform, unlocking energy, spectrum, data, those are the ones likely to define digital leadership for the next decade.
That's the key takeaway, I believe. It's that combination of capital and progressive policy.
This has been Delphos Insights. Learn more at delphos.co.